Welcome to solverfy.
In this problem, we want to figure out what the amplitude of vibration of the trailer is in the previous problem if we're given the velocity, and that velocity is 15 kilometers per hour or 4.17 meters per second. So again, we have a wavelength of the pumps in the road of 4 meters. The frequency is the velocity divided by the wavelength. Okay, so that is the circular frequency. The linear frequency. So this is in hertz. Now, to get the excitation frequency, we just need to multiply by 2 pi to get it into radians per second. So this is in hertz. So this is, you can think about it as, how long does it take the time, the inverse of the time it takes to go through one cycle, okay, or the time that the cycles per unit time. If you just kind of look at the problem and look at the geometry and think about this trailer going over, you can see that this is cycles per second, or bumps per second, I guess you could say. So to get it in radians per second, we need to get there's 2 pi radians per cycle, so it's oscillation cycle. And so in this case, we're asked to say, well, what is the natural frequency? So the natural frequency, we can think about it as it's the speed, the resonance speed. Okay, so when the natural frequency is given in terms of a speed in this case, and we do that just because we can then cancel some things out, and the wavelength turns out to be cancel out, but we actually we calculated this using the wavelength, so it doesn't really cancel out. It's still part of the problem. Anyway, there's a speed at which the natural frequency occurs, and that is 2 pi v sub r over lambda. So when we're looking for the amplitude of amplitude of the response, it is 1 over the amplitude, or the magnitude, the absolute value of the amplitude of the excitation, which we were told in this case is, let's see here, is actually 50 millimeters. I didn't write that down here, but the total, the peak to peak is 100, so the amplitude of the harmonic excitation is half of that. So this is 50 millimeters, and then we have 1, and then we have the forcing frequency divided by the natural frequency, and if we use these expressions, we see that that is actually turns out to be the velocity squared divided by the velocity when resonance occurred squared. And in this case, we were given this, and we have this from the previous problem. It's 1.2 meters per second. So we're actually going quite a bit faster. So this thing is going to be greater than 1. So this thing will be negative, but we take the absolute value to find the magnitude. And it turns out that the response amplitude is about 4.53 millimeters. So, and we can see that it's quite a bit less than the excitation amplitude, which was 50 millimeters. And that is because this denominator is quite large, because this term is quite large. This term is roughly 16. So this was roughly 4, this was roughly 1, so this is roughly 16, so this is roughly 15, or minus 15. So we're attenuating this amplitude of our excitation by a factor of roughly 15 to get to our response amplitude.